So this is 7.4, part 1, trigonometric functions of any angle. So objective number 1 asks us to find the exact value of trig functions of any angle. In the last section, we were able to find the trig values of 30 degrees, 60 degrees, and 45 degrees. But the other values have to be addressed. And if we know where a point is, then we're able to figure out what those values are. So if we look at the yellow box, and it says let theta be any angle in standard position, and let A, comma B denote the coordinates of any point except the origin 0, 0 on the terminal side of theta. So we're talking about where the angle ends, okay? And if you don't want to use A and B, we can use X and Y instead. It furthermore goes on to tell us that if the radius, or r, equals the square root of a squared plus b squared, then that denotes the distance from 0 to 0 to that point, x comma y. Then we can come up with the definitions of the 6 trig functions. So the first one is sine, and sine is going to be found by taking y over r. Cosine is going to be found by taking x over r. Tangent, remember tangent sine over cosine, so tangent becomes y over x, because sine is y over r, and then you're dividing that by x over r. And if you write this out, because this is a complex fraction, by taking the denominator and flipping it over, you will find that the r's cancel out and you're left with just y over x. Okay, so we have sine, cosine, and tangent. Now all we have to do is find the reciprocal function. So cosecant, which is the reciprocal of sine, is going to be that radius over y. Secant is the reciprocal of cosine, so we get r over x. And cotangent, which is the reciprocal of tangent, is x over y. So here's a little mnemonic device, or a little saying, sinier. It sounds like you're saying shiny, but sinier. And then cosexer, it sounds like Costco or something, so cosexer. And then tangent just notes sine over cosine, so y over x. Alright, so once again, r is a radius. So if we look at this figure, we have a terminal point, and let's call this x comma y right here. So I'm just going to erase that off of there and rewrite it so it's a little bit clearer. So x over x comma y, that's your terminal side. So if I draw a triangle by extending down the height and drawing this part over here, I get a right triangle. So the height of this triangle is y, and the width is x. Now, theta of this triangle is always going to be the angle that is formed with the x-axis and the terminal side. Okay, so we can redraw it like that, and we can see why sine is y over r, because y is the opposite side from theta, and r is the hypotenuse. So we still are using our definitions, opposite over hypotenuse for sine, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you're able to draw the right triangle, you're able to use these definitions instead of using y over r, x over r, etc. But they're the same thing. Alright, so let's look at this next example. Find the exact value of each of the sig trig functions of the positive angle theta, and I put a note here that we're going to use this value 3 comma negative 2. So the first thing I want to do is draw this out because I want to know which quadrant I'm in. So a positive 3 is for the x-axis and a negative 2 is for the y-axis. So if I draw this angle, my terminal side is falling in quadrant number 4. So if I complete the triangle, I have this bit of information. So we have 3 here. I'm going to put negative 2 as the height. I know we can't have a negative 2 as a height, but I'm going to put it in there just for the the value, and theta once again is formed with the x-axis and the hypotenuse, okay? The terminal side, the hypotenuse. So the first thing I want to do is I need to establish what is what. So I'm going to draw out that triangle again just so it's a little bit more clear. So I have theta here. -2 is going to be the opposite side. 3 is going to be the adjacent side, and the hypotenuse is unknown. So I'm going to use Pythagorean theorem to figure this out. So remember, it's a squared plus b squared equals c squared. Okay, so my a value is opposite, so we're going to put -2, I'm going to square it, plus my adjacent side, which is 3, and it's going to equal my hypotenuse squared. So -2 squared is 4, plus 9 equals h squared, 13 equals h squared. H is going to be the square root of 13. Okay, so now that I have that, I have r. So what does r equal? R equals the square root of 13. So at this point, you can either use the first definitions you learned, or you can use the definitions we just went over, because like I said, they are the same thing. They are the same thing if you are able to draw this out like I just did. Okay, so sine. The definition that they gave was y over r, or opposite over hypotenuse. Okay, so let's write out what we know. The opposite side is -2, and remember that's y. Okay, the adjacent side is 3, which is the same thing as x. And the hypotenuse, which is still the hypotenuse, either way you go, is the square root of 13. Okay, so if I write that out, I get -2 over the square root of 13. I've got to rationalize that. So I'm going to multiply both by the square root of 13. So I get -2 radical 13 over 13. Okay. If I get the reciprocal of sine, remember the reciprocal sign is cosecant. So by definition, it's r over y, or h over o. So if I flip this over, I get the square root of 13 over -2. So I can write this out as negative radical 13 over 2, and the second one's done. Next, let's go after cosine. So cosine was defined as x over r, or adjacent over hypotenuse, either way. So we have 3 over the hypotenuse, which is radical 13. Once again, this is going to require me to rationalize this. So I get 3 over radical 13 over 13, and that's simplified. The reciprocal function of cosine is secant. So this is defined as r over x, or h over a, same thing. So radical 13 over 3, and I'm done, because that is good. Doesn't need to rationalize because I have the radical in the denominator, or excuse me, in the numerator. Alright, tangent. Tangent is defined as y over x, or opposite over adjacent. So the opposite side, remember, was -2, the adjacent was 3, and I don't need to rationalize that because I don't have a radical in the denominator. Cotangent is the reciprocal function of tangent. So I have x over y, or a over o. So just flip that over, and I get 3 over -2, or -3/2. So those are the 6 trig functions using those definitions. And like I said, if you are able to draw out the triangle, and remember that you draw out the triangle with the angle resting in between the hypotenuse and the x-axis, you'll be fine. Or you just use y over r, x over r, or y over x. Same thing. The next example asks us to use a unit circle. Now we haven't talked about the unit circle yet, so what I'm going to do for you is I am going to draw out a circle, and what I'm going to do is I'm going to show you guys a piece of the unit circle. So we are just going to use the quadrant angles. So the quadrant angles, remember, are 0 degrees or 360, 90 degrees, and then 180 degrees, and then 270. Okay. So remember that 0 degrees is 0 radians, 360 is 2 pi, 90 is pi over 2, 180 is just pi, and 270 is 3 pi over 2. So there's a radian equivalence. So now we're going to talk about these values. If it's on a unit circle, that means that the radius is 1. So this is very important. The radius equals 1 on a unit circle. So we just have to label these points. So at 0 degrees or 360, this point, since the radius is 1, is 1, 0, because I have movement on the x-axis but no movement on the y-axis. At 90 degrees, now my radius is 1, but it's in the y direction, and I have no movement in the x direction, so that point is 0, 1. This point here at 180 is a negative 1, 0, and at 270, this value is 0, negative 1. I also should mention that on the unit circle, the x value will correspond to cosine, and the y value is going to respond to sine theta. And the reason why is because of the definition. Remember that cosine is defined as x over r. And if my radius is 1, then cosine is just x. Sine was defined as y over r. So once again, if my radius is 1, then sine is just y. So that's why those points correspond to cosine, sine. So cosine goes with x, and sine goes with y on the unit circle because the radius is 1. So now getting back to what they're asking us, part A asks me, what are the 6 trig functions when the value is at 0 degrees? So I have to find sine at 0 degrees. So once again, look at 0 degrees, read off the y value, and you'll see the y value at that point is 0. Then I have to find cosine at 0 degrees. So cosine, remember, corresponds with the x coordinate, so cosine's 1. Tangent at 0 degrees, remember tangent is sine over cosine, or y over x. So my y value is 0, my x value is 1, so 0 over 1 is 0. Okay, now we do the reciprocal functions. So the reciprocal of sine is cosecant at 0 degrees. So I'm going to throw 1 over sine. So 1 over 0 is undefined. I cannot divide by 0. The reciprocal function of cosine is secant. So secant is 1 over cosine. So 1 over 1 equals 1. And cotangent, remember, is defined as 1 over tangent. So I get 1 over 0, which is undefined. Okay, it does not exist because you can't divide by 0. Okay, so that's how we do part A. Let's look at B. B is asking us to look at 90 degrees or pi over 2. So sine at 90 degrees. Now I'm looking at the y value at 90 degrees, and the y value is 1. Cosine at 90 degrees. Now I'm looking at the x value at 90 degrees, and that's 0. Tangent, remember tangent is sine over cosine or y over x. So my y value is 1, and my x value is 0, so I have undefined. Okay, now for the reciprocals. The reciprocal of sine is cosecant. So basically, I am taking 1 over my sine values. So 1 over the sine value is 1 over 1, which is 1. Secant of 90 degrees, I'm taking 1 over my cosine value. So I get 1 over 0, which is undefined. And cotangent, remember, is 1 over tangent. So if I'm looking for cotangent of 90 degrees, I'm getting 1 over my tangent value, which is 1. Okay, so you can flip this over. So I have 1 over 0. Remember, cotangent is x over y, right? So what I can do is write 0 over 1, which is 0. Okay, so if you can't take 1 over undefined, so you have to just flip it over. All right, guys, let's look at C. C says I have to find 180 degrees or pi. So sine at 180, once again, I read off my y value at 180, which is 0. Cosine at 180, I read off my x value, which is negative 1. And tangent at 180, remember we do y over x. So my y value is 0, and my x value is negative 1, so I get 0 for that one. Okay, so I have the major 3, now I have to go get the rest of them. Cosecant is the reciprocal of tangent, so I take, cosecant is the reciprocal of sine. So I'm going to take 1 over 0, that's undefined. Secant of 180 degrees is a reciprocal of cosine. So I take 1 over negative 1, which is negative 1. And then cotangent, it might be best when you do cotangent to just take x over y. So if we take x over y, we get 0 over negative 1, which is 0. And then part D asks us to find 3 pi over 2, or 270. So sine at 270, I have to look at 270 and read off my y value, which is negative 1. Cosine at 270, I have to read off my x value, which is 0. Tangent at 270, now I'm going to use that definition of y over x. So we have y, which is negative 1 over 0. That's undefined because I cannot divide by 0. Okay, now the reciprocals. Cosecant of 270, reciprocal of 1 over sine. So my sine value is negative 1, so 1 over negative 1 is negative 1. The reciprocal of cosine is secant, so I'm looking for secant of 270, so I'm taking 1 over cosine. So 1 over 0 is undefined. And then finally, I have to do cotangent. So once again, for these, I would highly advise to do x over y, because remember that's a reciprocal of y over x. So my x value at 270, remember, is 0, because that's cosine, over sine, which is negative 1, and that's 0. So there you have it. When we look at these, you will notice that sine and cosine never are undefined, but tangent, cotangent, cosecant, and secant, depending on where you're at, could be undefined. So when we do the graphing of these, you're going to see that we get vertical asymptotes in some instances, well, actually in all the instances where they're undefined. Okay, so we just did all that work, and this little box here, I used to make people do workbooks that you could port over with you to calculus, but my advice is just to keep your whole entire note packet, so that way you can look back in case you are, a little bit rusty on any of these things. And that brings us to objective number 2, using coterminal angles to find the exact value of the trig function. This section is very important because if you have the same terminal side, that means you have the same value. So two angles in standard position are said to be coterminal if they have the same terminal side. So if we look at this, angle A, which is a positive angle, its terminal side is right here in quadrant 2. And then we have angle B that's a negative angle, but its terminal side is the same position as angle A. So those two are said to be coterminal. If you have a value that you are looking for and it's over 360 degrees, you're going to have to just subtract 360 to get it to be where it's an angle that is in standard position. So, if we look at this, it says find the exact value of each of the following. If we look at part A, they're asking us to find sine of 390 degrees. Well, we don't know that, but we do know that 390 is bigger than 360. So what you can do first is take 390 and subtract one rotation from it, which is 360 degrees, and I come up with 30 degrees. So what they're actually asking you to do is find sine of 30 degrees, because sine of 30 degrees is coterminal with sine of 390 degrees. In order to do that, you can rely on those triangles that you learned in the last section. And remember, we have 30 degrees here and 60 degrees here. So we have 1, 2, radical 3. So sine is opposite over the hypotenuse of 30 degrees. So the answer to this is going to be 1/2. So sine of 390 degrees is the same as sine of 30 degrees, which is 1/2. B, cosine of 420. So do the same thing. Take 420 less 360, and when we do that, we get 60 degrees. So we're actually looking for cosine of 60 degrees because cosine of 60 degrees is coterminal with cosine of 420. So once again, we can use our 30, 60, 90 triangle. And by the way, you have to have these triangles memorized. It's the only way to survive. Okay, so I'm looking at 60 degrees and cosine is adjacent over hypotenuse. So cosine of 60 degrees equals 1/2. C, tangent of 9 pi over 4. You have a couple of choices here. You can either change these from radians to degrees and figure it out that way, or you can leave it with the fraction. So listen, 2 pi. If I have a denominator of 4, I have to double the numerator. So double of 4 is 8. So 2 pi over 4, or 2 pi is equivalent to 8 pi over 4. So if I take 9 pi over 4 and I subtract 8 pi over 4, and by the way, you have to change 2 pi to a denominator of 4 to be able to subtract these, I'm left with pi over 4. So tangent of 9 pi over 4 is the equivalent of tangent of pi over 4. So pi over 4 is equivalent to 45 degrees, so I'm going to use a 45 degree triangle. Remember, that's 1, 1, radical 2. Tangent of 45 degrees is opposite over adjacent. So I get 1 over 1, which is just 1. D. Now we're getting into negatives. So we're looking for secant of negative 7 pi over 4. So remember, a negative angle, we're just looking for that terminal side. So if we're looking for the coterminal angle in standard position, I want a positive angle. So I know from the last problem that 2 pi, or 360, is equivalent to 8 pi over 4. So if I take and add 8 pi over 4, which is 2 pi, to negative 7 pi over 4, I'm left with pi over 4. So I'm looking for secant of pi over 4, which is coterminal to secant of negative 7 pi over 4. Okay, So once again, the 45 degree triangle. And remember, secant is the reciprocal of cosine, so I'm looking for hypotenuse over adjacent. So hypotenuse over adjacent is going to be radical 2. That's hypotenuse over the adjacent side, which is 1. So the answer to this is going to be radical 2. And finally, E says we have cosecant of negative 270. So we do the same thing. This time we're in degrees. So 2 pi, remember, is 360, right? So 360 plus that negative angle. We subtract those two. So if I subtract 360 minus 270, I get 90 degrees. So I'm actually looking for cosecant of 90 degrees. Now remember, on the unit circle, 90 degrees is right here, and that value is 0, 1. So cosecant, remember, is the reciprocal of sine. So I'm actually looking for 1 over my sine value. Remember, sine is y. So I'm looking for cosecant of 90 degrees. I'm going to get 1 over my y value, which is 1. So the answer is going to be 1. All right. So this is how this is working. So to find the coterminal angles, you have to take and either add 360 if it's a negative angle, or subtract 360 if it's a positive angle. And by the way, if you have several rotations around, we're letting this stand as k. K equals the number of rotations that you're taking around the unit circle. So that's how this is working. So that's why with degrees, 360 is your magic number, and in radians, 2 pi. And don't forget, if you're dealing with something that has a denominator, you're going to have to find a common denominator to be able to add or subtract them. Okay, I'm going to stop this video and we're going to pick up on objective 3 for 7.4 part 2.